I'm Dr. Lane, and these are my students Erin and Alex and Marisa. Thank you for your donation to fund our research, and our laboratory studies ways that we can use nutrition and diet to stop metastatic colon cancer. What Marisa is actually doing is she's freezing some cells. The cells that we predominantly use right now are cells that were recently derived from human colon cancer patients, so within the last couple of years, and we received them from a cell repository at Texas Tech. And the advantage of these cells is that they're less derived than cells that have been in culture and are commercially available. Because the ones that have been in culture and are commercially available, they've been there for 20, 40 years. So they've evolved to live in a tissue culture dish, and we want to know what a tumor from a person would do when it was exposed to vitamin A, as well as we're going to start looking at omega-3 fatty acids. And so what she'll do is she'll put the cells in a media that you can freeze them in, and then they can survive. We can keep cells in here for, as long as there's liquid nitrogen, they stay frozen for decades. Erin is actually going to be working on, we have a mouse colon cancer cell line, so you can take human colon cancer cells, put them in an immune compromised mouse and get colon cancer. The problem with that is that the mouse doesn't have an immune system, and vitamin A regulates your immune system, and so do omega-3 fatty acids. So if you use a mouse without an immune system, which we've done, and vitamin A works great, but it's not that relevant to the human model. So, I mean, it's relevant, but it's not ideal, because we now know that the immune system plays a tremendous role, as well as our probiotic bacteria, and these mice don't have the full complement of probiotic bacteria. So what Erin's going to do for his thesis project is he's going to take the mouse cell lines, he's going to see how they respond to vitamin A in a tissue culture, which is in a dish, and then we're going to try to get them to grow in mice so that we can have colon cancer in mice. We use a new surgical technique called orthotopic injection, where we put them in the mouse's cecum, which is analogous to our colon. And the advantage of that is that the mouse will have an immune system, the mouse will have bacteria, and then we'll be able to feed the mice different diets and see how they affect the metastasis. And it should metastasize to the liver. So we're trying to take the humans and mimic it in an animal, because you have to complete your preclinical work before you get to do clinical work. And Alex, she characterized those human cell lines. So she figured it out. She's found out they respond to vitamin A, and that one of the two is metastatic. So she's characterizing them so we can compare them between different cell lines, and because each cell line is a different person. So we're kind of trying to build a more relevant human model system to then test different diets on.